1,000 years ago was that the magnetosphere's strength plummeted to about 4% of its recent values, and it also tilted on its side. According to investigations conducted in the past, it was previously thought that the magnetosphere disappeared completely on the day side, which faces the brunt of the solar winds. But the most recent models tend to differ with previous analysis. The most recent data compiled on the planet's magnetism from ancient rock sediments as well as volcanic data during the Lachamp period indicate that although the magnetosphere shrank to about 3.5 times the Earth's radius, it did not disappear entirely. Instead, what happened during this period of time was a reversal excursion in which the magnetic strength dropped enough to allow the poles to move toward equatorial latitudes, and the solar particles that produced the auroras followed the movement of the poles. At that time in our Earth's history, the geomagnetic tilt was greatly skewed from its geographic location, which allowed the auroras to follow the magnetic poles and relocate towards the equator. The Lachamp excursion led to a decline in habitability and was responsible for plunging the Earth into an environmental crisis. The new models are suggesting that this was the likely outcome of the magnetic pole shift in the prehistoric period 41,000 years ago. The new data is disconcerting because earlier this year, researchers had found that a weakened magnetosphere would have easily been penetrated by the solar winds, leading to a damaged ozone layer, to climate upheaval, and to the eventual extinction of entire species. The animation from the European Space Agency is showing how the Earth's magnetic field is weakening, specifically in the area of the South Atlantic, where the white dots on the map indicates instances in which the satellite detected radiation, in which you can see the frequency increasing over a period of time between April of the year 2014 and August of 2019. Although the findings are not indicative of a cause and effect relationship between magnetic changes and ecological repercussions on Earth, the findings provide some insight on the predictions of what may be taking place on our planet at this time. With the magnetic field in a state of declination, there is a tendency for volcanic activity to increase, and that is exactly what we are witnessing in locations across the globe. On December 20th, an intense, powerful explosion took place in the South Pacific near the island of Tonga. The volcano, Hunge Hape, produced a massive gas cloud some 59,000 feet into the atmosphere. The loud explosion was heard more than 150 miles away in nearby islands. The Tonga Geological Services put out a warning that the dust and gas from the explosion could result in acidic rainfall if mixed with moisture in the atmosphere, potentially poisoning drinking water and damaging skin and eyes of those who come in contact with the toxic mixture. Spectacular bursts of lightning were also present at the top of the cloud formation. Coincidentally, the last eruption of this volcano began on December the 19th, 2014, and ended on January the 23rd of 2015. That eruption created a new island, which is now the site of the latest eruption.